Good morning, everyone. Welcome to our webinar today, brought to you by Merck Life Sciences. Our webinar today is titled A Greener Future, Waste and Waste Reduction. Our three event speakers today that you'll be hearing from are Professor Usha Iyer-Raniga from RMIT, Professor Veena Sahajwalla from UNSW, and Professor Sujeeva Setunge, also from RMIT. Your moderators today are myself, John Roniotis from Merck, and also Rachel Khaleesi from Merck. Before we get into the event, a few housekeeping details. The session will be recorded for everyone, and the content will be available at a later date, and that content will be available from our Merck Life Sciences YouTube channel. Feel free throughout to ask questions using your BlueJeans Q&A tab. Ask questions for the presenters, and at the conclusion of the third speaker, we'll have an open Q&A session where we'll read out some of your questions and have them answered by the presenters. Look out for some announcements that might be coming from us throughout the talk, and also you are on mute, remember that, and your videos are also off, so we can't see you. So again, anything you need to ask or chat about, please put it through the BlueJeans channel. You'll see now there's a poll that has started. We have three poll questions before we kick in. So please, if you can, send to those poll questions, and we'll at the conclusion of the third question, we'll move over to our speaker, which is Professor Usha. So, Professor Usha comes to us from the School of Property and Construction Management at RMIT. She works in government, industry, and academia, or has those partners. She is developing and leading and managing innovative projects for the government and the private sector. She is a co-lead from the One Planet Network and United Nations. Her interests are in sustainability of the built environment, achieving practical solutions to ensure sustainable outcomes for users of the built environment, and working on circular economy. We are very privileged to have Professor Usha here today, and she'll spend the next 10 to 15 minutes talking about her interests and her research. Before we get into that, our poll questions are still running, and I'm just going to have a look at our poll questions. We're up to our second poll question. We're just going to pause a little bit while the poll questions are completed. So we'll have the answers for you for these poll questions at their completion, and straight after the answers of the poll questions, we'll get into Professor Usha's talk. So how many poll questions are we up to? I think we're on the second one. We'll get onto the third one as soon as possible. And I might just flick up to this slide and preempt that third one for you all. And from there, Professor Usha will start speaking. So here's our poll questions. Poll question one, globally, buildings account for what percentage of energy consumption? The answer there is 40%. Poll question two, by 2035, what is the potential for global energy savings attributed to the built environment? 40% there as well. And the last question, by 2050, municipal solid waste globally is expected to change from 2 billion tonnes in 2016 to, and the answer is a lot, 3.4 billion tonnes. So I think you all, if I'm looking at the poll here, you all pretty much got the right answer, so for each of them. So well done to each of you. Now, I'm going to pause here, and Professor Usha will take over.
Thanks very much, John, and I hope you can see the screen that I'm sharing with you. Please shout out if you cannot.
Yes, we can.
Okay, great. Excellent. Looks like I'm speaking to a very informed audience here today, and it's great to know that you've already got the information, or at least most of you have got the information on your fingertips, because I haven't actually seen the total poll results, so some of you possibly have made some mistakes as well. This information that I set up for the poll comes from a number of resources, but mostly through the International Resource Panel that has been doing a lot of work on looking globally at our production and consumption patterns, particularly in the built environment. And it's also interesting to note, as another tidbit before I start my presentation, that the construction and demolition waste here in Australia is about 45%, and if you compare that with Europe, for instance, it's only about 30%. So we still have to do a lot more in the Australian context to try and reduce the amount of waste that we generate through the buildings and construction sector. So what I'm going to run through today is take you through the work that I've been doing with the Buildings and Construction Program of the UN. I just seem to have some trouble. Oh yeah, here we go. You should be seeing my next slide. So this work that I'm presenting to you today has been done for the Sustainable Buildings and Construction Program. There's a team of 3 of us who co-lead this program, myself based here in Australia, Pekka Hovila based and representing the government of Finland, and Jonathan Dewin working with UNEP in Paris. And a lot of this work is also available as resources on our Buildings and Construction website of the One Planet Network. A little bit more trivia to set the context for the presentation. The built environment, as we know, has, and as the polls have demonstrated, is a very high resource use sector, but at the same time has also resulted in a lot of greenhouse gas emissions, and therefore has a huge impact on the planet and on our ecosystem. The built environment consumes about 40% of raw materials, and it's not just in the process of construction of buildings, but it's also throughout the life cycle of buildings. So it's the construction of buildings, it's the operation of buildings, and of course, what we have been calling as demolition of buildings really needs to change into deconstruction of buildings, so we can use some of those materials at the end of life into another building project or into another use. As the polls have demonstrated, and just as a reminder, the process of building and construction uses 30%, uses 40% of materials, but creates about 30% of waste in the process. And again, this is not just in the process of construction, but across the life cycle of the buildings as well. There's 30% water use, again, through the life cycle of buildings. And the most important thing, I think, which a lot of governments are interested in, is the economic opportunities or job opportunities associated with buildings and construction. And often what's happening from an economic perspective is related to building and construction activities in the country. And here again is a good example of Australia, that despite the pandemic, the building and construction industry is still booming, perhaps not at the same pace that one would have expected before the pandemic, but it's still a key churner of the economic activity across the different states in Australia. In Australia, about 9% of our total workforce is associated with buildings and construction in terms of its contribution to the GDP. But when we start thinking about the developing countries, a lot of these are also, which is usually not counted, is also attributed to the informal sector. From a materials use perspective, and that's really critical when we start talking about circular economy and the impact of the built environment, according to the IRP and the OECD, material use is going to double by 2060, and most of this material use is going to be in the new growth regions of the world, in the cities of Asia, Africa, and Latin America. And the materials that are going to be used are what has been used to date. So the trends of material use are expected to continue with cement, sand, gravel, limestone, glass, etc. So what does a circular economy actually mean? I seem to have trouble in advancing my slides here. I hope you can see that now. The circular economy is really about designing waste, but keeping products and materials in the system that are already there. So we're not using virgin materials. And I'm sure Veena is going to give you some fantastic examples of how we can use products and materials that are used in one system, reusing into another type of system or into another type of product. And the important thing here is to remember that we've just got the one planet, and therefore we cannot continue to pillage this planet that we've got. As I said before, most of this material use is going to be in the developing regions of the world. But also, when we think about the Australian context, Australia, again, this was before the pandemic, but the Australian population is expected to increase to 40 million by 2050. And there is going to be a mix of greenfields developments, brownfields developments, and greyfield developments. And if we continue again to build cities the way we have, build them horizontally rather than building them vertically, we will also be responsible for a large proportion of primary material use in the Australian context as well. But if we were to move to adopting a circular economy lifestyle, then what are some of these advantages? Clearly, the advantages are that we will not have to rely on production and consumption and manufacture of materials through virgin resources. And this will assist us in eliminating environmental impact. But more importantly, it's also supportive of local growth, local jobs, and local economies. There are many options available when you think about the built environment sector. Some of these options are mandatory, some of these options are voluntary. So some of these mandatory options, for instance, are tying in with building codes, building regulations, various assessment schemes that arise out of the building codes, but also that have been driven through voluntary schemes in the marketplace. National determined contributions, which is a reporting mechanism by countries through to the Paris Agreement, is another area, and Australia hasn't quite signaled the importance of the built environment in this, but the recognition of reducing impact of the built environment is certainly part of Australia's NDC reporting. It's also important to start thinking about policies. So some of the measures towards low carbon economy, towards the use of efficient processes within the system, towards thinking about procurement practices, particularly by governments, thinking about what Australia is going to look like in a zero waste economy or in a low carbon economy. These are all some of the things that are really important when we start thinking about some of the mandatory top-down driven measures. Voluntary options are often, at least in the Australian context, led by industry peak bodies, but there's also an increasing demand now coming from clients and consumers, and particularly the millennials and Generation Z are very conscious of the impact that we as humans are having on the planet. I'll now turn to a report that was produced by the SPC program, where we looked at what is the state of play of circular built environments across 7 regions in the world. I authored the one for Australia and New Zealand, and also assisted in setting up the reports across Asia, Africa, Latin America, Gulf Cooperation Council countries, North America, Europe, and then we brought it all together through a global report. And these are the recommendations that we have outlined in our global report. Things like moving the whole world into thinking about from the linear system that we currently operate in into a more circular system. So thinking about how can we bring that into our everyday thinking and into our practice. Obviously, the role of monitoring and reporting is going to be critical in this process. Again, the importance of life cycle, which I've talked about earlier, so not just about the design of buildings, but also the operation and end of life of buildings. And the role of materials in the process is very, very critical, and has been demonstrated through the polls and through the facts that I have that I have shared with you, the materials that are used for making our buildings are the essential building blocks, and we have to start thinking about either different material use or different types of materials, such as bio-based materials. The role of adaptation and resilience, and we're seeing this increasingly into the media, but also into the context of discussions in our own disciplines, that we can't just think about mitigation. We have to start thinking about adaptation and resilience as well when we talk about the built environment. And as the pandemic has shown us, global supply chains can be a problem. So we need to start thinking about exploring local opportunities, local solutions, local practices, which in turn create jobs at a local level as well. And sitting all this, of course, are new business models. So moving away from models where we own things into models where we're sharing more and more things. And this requires us to start thinking differently, but also educate and reskill a new workforce that is prepared to deal with the world in 2050 and beyond. And to support all this, also the importance of financing arrangements, new ways of sharing opportunities, new ways of financing, moving away from the old design, build type of models, particularly for the built environment. I'm just going to run through these very, very quickly because I'm running short on time. So some of the things that point to or needs to be considered when we're thinking about systemic change, moving from a linear thinking to circular thinking, are around supply chains as well, thinking about how do we engage clients and consumers within this process, but also thinking about some of the leadership that governments can show us in the process. In terms of adaptation and resilience, as I've said already, the role of how we tackle climate change, how we tackle about people's responses to climate change, and the role that people can play in the process is just as critical. And this brings us to the importance of skilling and reskilling. And this may happen not just at a vocational level or at a higher education level, but it also needs to bring in professional development opportunities across the different disciplines that make up the built environment. And also starting to think about more of a repair culture rather than a throwaway culture. In terms of the life cycle thinking, I've talked about the importance of thinking the full life cycle of buildings, but again, within this, the importance of new educational opportunities and reskilling people within this process is critical. And so turning the attention towards new jobs that would be in the green building space, that would be in the green skill space is critical. In terms of the materials itself and the role of materials, it's really important to start thinking about bio-based materials, about using materials, the cradle-to-cradle type of approach. So again, we are not using more chemicals within the process, so it's easier for us to reuse these materials at the end of the useful life. In terms of the procurement practices, again, moving the ownership models of owning into sharing. So for instance, companies that would be coming in and putting solar panels on your roof and taking responsibility for maintaining these solar panels. So you don't actually use them, but you come to an arrangement of working with these companies to set up these systems in place, and they take responsibility for ensuring that the panels work. And there are examples of this already in Europe and in the Americas. Again, sharing spaces, sharing desks, and we've changed the way we work. So there's opportunities for us to start thinking about, rather than owning office spaces, to start sharing office spaces. And then in terms of the locally adapted solutions, thinking about how we can support the local economy. So this repair culture, the sharing culture, what role do new jobs, new opportunities create within that space? And this, of course, lends itself to new different ways and new ways of business collaboration, financing, and bringing in new ways of working, and some of which we've already seen, virtual ways of working, thinking about procurement models within this process as well. And the role of monitoring and reporting in this whole process is quite critical, because we need to start thinking about, we've already got the Sustainable Development Goals as great indicators to enable us to get to where we need to go into the future. So, using this backdrop of the Sustainable Development Goals to start thinking about what are some of those SDGs that will assist us in this journey to get there. So we carried out a poll, and this poll is still open. These were the results out of the first 80 or so polls that were conducted. We now have moved to almost 150 responses from different parts of the world, where we asked our built environment community about what were the core indicators that they felt were critical in the transition to circular built environments. And unsurprisingly, SDG 12, which is related to our consumption and production patterns, came up as being very important, followed by SDG 11, which deals with the built environment, resilient and sustainable cities and communities, the role of climate change. So again, a recognition that we don't need to be thinking just about mitigation, which is where most of our efforts have been to date, but to start thinking about the impact that climate change is having on the planet as well. And this is going to have some fundamental impact on the way we build. So for instance, the Building Code of Australia has got zoning depending on the climates across different parts of the country. And as, for instance, Melbourne climate moves to a more warming climate, or Tasmania's climate moves to a more warming climate, we need to start thinking about removing this heavy thermal mass that we've had in our buildings and move towards lighter construction of buildings. So that is going to have an impact on material use, and obviously have an impact on how the building community itself needs to start thinking about its approach towards the way we build within these spaces, within these regions. And of course, thinking about industrialization. So what are the new technologies? What are the new practices? What are the new things that we need to consider? And as I said before, SDG 8, which is linking with economic growth, has also been considered to be quite an important aspect that a number of our built environment experts identified. So some of the other areas that link to the built environment, such as water, the use of water, health and well-being, which is really important in the spaces that we live and work in, the importance of global partnerships, the importance of SDG 15, which is about biodiversity. And as we build more, we are actually taking away biodiversity existence, and we're changing the landscape, we're changing the flora and fauna within these landscapes. And this is a huge issue as we start using more and more greenfield developments. And of course, the role of education in the process. So what this exercise then delved further into was what were those indicators. So there were 4 core indicators, actually 3, because 8.4.1 and 12.2.1 on material footprint are the same indicator, but across target 8 and target 12 within the SDGs. The role of recycling was considered to be really important, which is 12.5.1, and the use of local materials, particularly in housing, which refers to indicator 11C1 under SDG 11. And then, as I said before, a whole heap of other indicators relating to energy, 7, relating to water, relating to the role of partnerships, relating to the importance of carbon dioxide emission. So these are the 10 secondary indicators which I'm not going to go into in greater detail. But again, that signals the cross-cutting areas of the SDGs that are really important for us to consider when we think about the built environment. So as I said before, the survey is still open, and if you're interested, I would love to hear from you. And please feel free to, I'm sure this is going to be shared later on, so feel free to put in your response to the survey. And just to end with, if you're also interested in joining the Buildings and Construction Network, please check us out on the One Planet Buildings and Construction part of the program. And with that, I'll end this presentation. Thank you.
Thank you so much, Usha. Thank you for your time and your presentation, excuse me. We'll move on now to our second speaker of the day, which is Professor Veena Sahajwalla. So Professor Veena is out of University of New South Wales. She's the founding director of the Smart Centre. She is an inventor of polymer injection technology known as green steel. Not blue steel, just in case you're wondering, green steel. In 2018, she launched the first e-waste microfactory, and you'll get a little bit of an insight of that in a minute when we play a video. And in 2019, she launched her plastics and green ceramics microfactories. Veena is the director of the ARC Industrial Transformation Research Hub for Micro Recycling. She's a hub leader of the National NESP Sustainability Communities and Waste Hub. And for those of you who watch ABC's Australian Stories like I do, she was featured this year. So we're now going to play a quick short video that we have on Professor Veena's work, and from there we'll get straight into Professor Veena's talk.
What we are showing to the world is if plastic waste coming from e-waste can in fact be transformed into a really useful consumer product like spectacles, then there are endless possibilities.
One of the big worries with recycling at the moment in Australia is a lack of trust about what's actually happening to the recycling. And so having products that can actually be felt and tangible and worn on the face is the kind of thing that shows people, look, your recycling is going somewhere. We are finding solutions for it.
The fact that we can produce these beautiful, high-quality plastic filaments out of waste and use it for printing, it means that we're opening up a whole new economy where microfactories become part of the supply chain, creating new products out of recycled materials.
The opportunity is massive, and if we can get it right, e-waste is really critical, because if we can solve all the problems to do with that, then we can solve a lot of other downstream recycling issues.
Well, thanks very much, John, for that kind introduction, and thank you for sharing that video as well. I just wanted to, pick up on a couple of key messages as we've been hearing this morning. And Usha, what a fantastic sort of piece of work that you've presented to us, certainly picking up on some of the points you've been making also around the survey where you talked about SDG 12, for example, sustainable consumption and production, as an example of something that has come out of the survey also that's important. But it goes to the heart of this whole issue around accessing materials that are circular in nature. And if we can really achieve that circularity and showing that different kinds of materials can find different pathways, then it doesn't matter whether your plastic, for example, might have come from e-waste. It could then be converted into other valuable products. And indeed, for us, the kinds of things that we're starting to see where people are asking us to show how materials can actually be recycled and remanufactured, whether they are products that go into built environment or indeed products that go into our electronic devices. In all of these cases, we do, of course, have significant opportunities to show that we can indeed have a greener future where we actually see waste as a resource. So we should hopefully have a future where we don't see anything as a waste, but rather see as a resource. And in that regard, really just to be able to give you a sense of the kinds of resources we're looking at, using, for example, waste tires in the process of making steel, using different kinds of materials like plastics that I was talking about coming from cars, electronics, and using that for remanufacturing. And indeed, what we have also shown that we've got complex mixtures of materials that allow us to indeed, reflect on where these waste materials can indeed be utilized. So if we're talking about processes like what we're doing now with green steels, we're showcasing that indeed we can use materials like tires and different kinds of complex plastics in the process of making all kinds of products that we've talked about here. So it's really about ultimately showcasing that we have to go beyond that sort of traditional thinking of the 3 R's of reduce, reuse, recycle, because our wastes are complex. So whether we're talking mixtures of different kinds of plastics, glass, rubber tires from cars, or indeed different kinds of plastics and metallics and glass-based materials from our electronic resources, we need to actually reimagine how our products can be used in remanufacturing. And this is where, of course, for us, the exciting future has been over the last many years at the Smart Center is showing that waste can be converted into value, which means we've got to look at all kinds of high-value products, and our consumer needs are going to change with time. The needs of our building industries, electronic industries, all of that will change with time. It's about being very flexible in the way we look at remanufacturing, but also at the same time recognize that the input feedstock, if it comes from waste resources, can be put into remanufacturing to meet the requirements of end users. So, if we're talking about things like e-waste, of course, our circuit boards are very rich in metallic resources like copper and tin. We know that the world, of course, has got plenty of these resources. It's about how do you transform them in a way that you can do it, not just in a traditional way of putting it into a smelter, but rather looking at how we can actually develop decentralized small-scale operations that allow us to manufacture and remanufacture these in a decentralized way. And so this is where, of course, development of our microfactories has come in, where we are transforming our materials into valuable feedstock for further manufacturing by doing it at a local scale, and that's really what these microfactories are all about. So if you look at something like this on the screen, where you're seeing printed circuit boards being converted into metallic resources, to do that in a micro scale, which is what you're seeing in the middle of the screen there, is to be able to generate these important metallic alloys, and to do it in a way that is possible to customize and target the kinds of alloys that you need, where your feedstock could be quite varied, different kinds of printed circuit boards. As devices get obsolete, of course, a lot of these old parts and components are going to become part of the waste stream. But if you can actually see it as a resource so that we can put it back into production again, and again, doing it in a decentralized way allows you to, in a very targeted manner, produce high quality metallic alloys, so that you can very much meet the requirements of an end user, depending upon what some of the new products are going to be generated, new devices that are going to be manufactured. So just because an old device becomes obsolete doesn't mean that that waste is no longer useful. We can reform them into metallic alloys, and by being very clever in the way we engineer and the way we customize our processes, we can actually produce these alloys. So this is what you're seeing in the middle of the screen there. We, of course, are very mindful of the fact that the need for metals like copper and tin, as the world moves more and more in the direction of electrification, is going to become even more important. So accessing these resources from our waste streams is going to be important for the world, but to do it in a way that is sustainable, that is safe, so you can actually design your products and parts and components. And so if you were embedding them even in your built environment, for example, you would want to make sure that you can retrieve some of the old parts and components and put it back into remanufacturing. And this is where, of course, a lot of that conversation around energy storage will come in, what happens to a lot of batteries, for example, whether they are, products like lithium-ion batteries, we know very well that they are, again, extremely useful. They contain very useful materials, for instance, like cobalt. So how do you harness these kinds of batteries in the production of important elements? So look, I'll just skip through a lot of these slides just to be able to give you a sense of the fact that lots of valuable materials, really sitting at our fingertips in the form of different kinds of batteries, for example. So the Smart Center really is all about taking that fundamental science, and we need to understand how recycling and materials transformation is going to play an important part, which means new recycling science has to be developed. We can't always assume that traditional methodologies are going to work, particularly when we are talking about highly valuable materials feedstock right down at the micro level, whether they are present in our circuit boards or indeed in our batteries. We need these new technologies so that ultimately we can harness those materials and micro factories, new recycling science like micro recycling provides that scientific and technological foundation, and those advances then enable us to achieve, of course, what we're talking about here today, a greener future where we are very conscious and mindful of the fact that our materials really are finite resources. So whether we're talking about electronic devices or just about all other things as part of our resource opportunity, including simple things like waste textiles, we need to be mindful that we need to ultimately deliver some of these solutions. And of course, green manufacturing and the work that we're doing in this space is important. I wanted to just maybe wrap up at the end by showing you some pictures. I'm sorry, I'm just going to skip through some of these slides, but just pictures to give you a sense of where these microfactories are. We've not only commissioned them at UNSW over the last few years, but also this year have launched our green ceramics microfactory outside UNSW in a regional town called Kudamandra. These types of facilities are enabling us to produce all kinds of products. So examples of what we do, some simple sort of solutions around conversion of plastics into 3D products that I was talking about earlier. All of that is feasible depending on the end market, but it is very much about customization, about creating what I like to call an EVP, an engineered value-added product, depending on the needs of our societies. So these are some of the solutions that I've talked about, but I also wanted to leave you with a few pictures. Our pictures that reflect here are panels that contain, for instance, glass and textiles, and creating these green ceramics means that you can actually put that back into end user application. So our collaboration, for instance, with Merck, which we've released into the public domain this year, and some of the docos and work that ABC has showcased, this collaboration shows that we can actually put these into actual applications. So this collaboration with Merck showing these pictures of some apartment that they've launched this year with products that are made from green ceramics. So you see these floor tile, island bench bases, including those that kitchen splashback and the wall tiles. So look, I'm conscious of the time. I'll leave it at that, and certainly leave you with a real positive hope for the future, recapping that UN SDG 12 of sustainable consumption and production, that is very much possible. So thank you very much for this opportunity, and I'll hand it back to you, John.
Thank you, Veena. Thank you very much. I think everyone in the apartment business will be glad to be using some of these recyclables, and it's timely. It's very timely. I'll just move on to our next speaker, our third and final speaker. So Professor Sujeeva Setunge out of RMIT University. Research interests vast. Enhancing the sustainability of civil infrastructure and developing new sustainable materials from recovered waste resources. Some of the projects that Professor Sujeeva is working on, I'm just going to go straight to my favorite one, which is changing the mindset. So changing the resource recovery value chain to enhance end user acceptance of recycled materials. So just changing everyone's mindset of accepting it. Director, a newly awarded ARC Research Hub, the TREMS, working on a number of things, including the circular economy, where they have 32 industry partners delivering novel solutions in behavioural changes, optimising sorting and processing of waste, and developing products from upcycled waste. Again, keeping with our theme of a greener future. So over to you, Professor Sujeeva. You're on mute still. Over to you, Professor Sujeeva. You're just on mute, so just unmute yourself and proceed. Can see your screen. We lost your screen and we go for it. Unable to see your screen. There we are. Yes.
Okay, can you hear me now?
Thank you. Everything's perfect. Thank you.
Thanks, John, and thanks very much to Merck Group for organizing the Greener Future event. This is a fantastic initiative, and also great to hear from the first two speakers who have set the scene very well. So I'll just move on to the topic straight away. It's really fantastic to hear the high-level overview from Usha about the global scene, and also from Veena about the scientific innovations and the great translation activities happening in the e-waste and also plastic waste space. So I will be covering the broader scope of resource recovery and circular economy challenges. So the background is I'm also a civil engineer and covering the built environment and construction sector, where the need was clearly identified and presented by Usha. So we have a huge opportunity and also issue. So some of the challenges we came across, we ran 6 engagement events with industry in developing a comprehensive research program. So some of the major challenges identified by the industry are the lack of knowledge about the volume and scale of the problem in detail, gaps in policies which also Usha touched on, minimizing waste and stakeholder responsibilities, effective tracking, collecting, sorting for a planned end use. So we have multiple opportunities for resource recovery and new solutions. What do we select? And the markets, loss of markets. So there are emerging changes. So we understand that there will be newer challenges happening in the near future with export markets being reduced. Then you have environmental issues, leaching, environmental hazards associated with waste, lack of business models. So you can develop solutions, translate them. How do we create a business model for the new product or the solution? And then cost-benefit tools and enablers to ensure that we have a circular solution translated well and implemented. So when we started, we looked at the opportunities available. There's a significant academic research delivering new solutions. If you look across the research space on this topic, you see that you have so many solutions being developed. However, what we noticed is that the translation is very slow, and it is a huge credit to Veena that she has taken this to the full value chain, and you are delivering now market-ready solutions to the e-waste problem, and then it's really fantastic to see the acceptance. So what we were finding is that in the construction sector, for example, geopolymer concrete, where we replaced cement completely from other additives, has taken 15 to 20 years to penetrate the market. Even when it has done that, the actual cost of the product is about 40% higher than the normal concrete. So how do you compete in that type of situation? So I think However, there are opportunities. So there's significant community awareness and expectations. All the sectors have pledges to achieve zero emissions by 2050, infrastructure boom, and whenever there is economic stimulus required, we see significant investments in the infrastructure built environment sector. So there is a huge opportunity for resource recovery and circular economy in the sector. And there's virgin material shortage. For example, 35% new quarries will be required for aggregate. So on the right-hand side, I have some pictures of the coarse aggregate we have manufactured in the laboratory using completely waste materials. However, this has been scaled up in USA because we couldn't scale it up in Australia. And after the pilot trials, the material is still has a long way to go before it is market ready for acceptance in the construction sector, because new quarries are still feasible and you have low cost aggregate coming out of new quarries, and you can actually use them rather than going for novel solutions. So there's energy recovery potential from the resources recovered, which goes into reduction in coal usage. So there are a lot of opportunities which encourage recycling. So considering all these, we developed a research program which covers 5 main themes. Theme 1 covers social change and smart design to minimize waste. Theme 2 is on processing, supply chain, and waste to energy. Third one covers solutions development, which is the space we have been working for the past 10-15 years, developing solutions from recovered waste for applications in the construction sector. Then we have a 4th theme where you do field trials, case studies, and then a 5th theme which covers enablers. And you can see the benefits of the interconnected themes. So when you look at the changing behavior, and look at intersection between processing, you see the reduction in contamination, which will enable easier recycling and upcycling of materials. Similarly, your social change and field trial intersection enables change of practice. So you can see the benefits of intersection of different themes. So based on this, we have developed a research program in partnership with 9 academic institutions, and I'm pleased to say that Veena's team is a participant in the program as well, and Usha is a key CI from RMIT. So we have 9 Australian partners, academic partners, and 4 international partners, and we do have industry partners covering the whole waste recovery value chain, local government to private industry and peak bodies. So this has given us a fantastic opportunity to develop a research program which actually enables us to minimize waste. And the first step of this is currently underway. We are developing a collaboration platform to track waste and material flows, working with 5 local councils who are key partners of the program. And we are also following on with some experience at Usha's team, where circular economy pilots have been conducted with local councils in other sectors, moving into construction sector and looking at C&D waste, and also reuse of materials in the construction infrastructure sector from different waste generated from different parts. So we are also looking at policies for waste recovery, looking at what has worked internationally and how can we bring some of these into local practice, and how do we change behavior of consumers, what are the most effective practices, and then how do we develop smart tracking and waste collection methods to enable recycling and upcycling. So optimized processing comes up as a major area within this as well, because what the industry told us is that you can come up with new solutions. How about the supply chain? Can we be confident that you have enough supply chain coverage to ensure that continuous supply of the material? So you need to address that. So we have a number of partners from this sector covering this gap in knowledge and also helping us to look at how do we move this forward. So we also have a fantastic new example where we have delivered a pilot plant of a pyrolysis technology developed by RMIT to convert low-value waste into energy with a low energy consuming process. So extracting of fibers, shredding, and some of these things we now also covered in her microfactory where it is already happening quite well. So in terms of new materials product, this is where our strength is. When you look at the 9 academic partners, we have 20 or so solutions which are developed at the laboratory scale, ready for that next stage of looking at field trials, case studies, which can be conducted in partnership with local council partners, and then developing enablers and tools which can quantify the benefit of using these materials to the consumer, enabling the translation and take-up of the solutions that are being developed. So the field trials, so the research program has 3 different types of projects. First one is field trials of mature technologies which are already developed and tested in the laboratory by the academic partners. The second type is focusing on application for the research that are currently in progress in our institutions. And the third type are the blue sky type research where very similar to what Veena has presented, developing new technologies like green steel or cement-free concrete or the like. So the enablers will be the tools and technologies which actually present not only the cost benefit based on economic considerations, but also social economic optimization. So circular life cycle is a concept we have introduced and a tool is being developed in that space. So moving into, conscious of time, moving into the full cycle. So I just want to flag one new project. We are currently progressing on upcycling solutions for hazardous claddings. So Grenfell Tower fire has created significant issues of cladding, and there's a lot of claddings being removed from buildings considering the fire issues, and recycling or upcycling of these has been a major challenge, and one of our CIs, Kate Nguyen, has been working on this project where she is looking at number of different outlets, so for the removed cladding and commingled waste. One solution is quite lateral thinking. Domestic footwears developed from the recycled cladding, and also prefabricated construction elements are another application we are looking at. I will wind up at this. Thank you very much, John, again for inviting us to present, and I'll be very happy to answer any questions.
Thank you, Sujeeva. Thank you very much, and thank you to all our speakers. It's been fantastic to have you present today. So we are into the Q&A session of the event. We have a handful, at least, number of questions that have come through. So we'll just ask them to. We'll read them out to you, and if the 3 of you can answer the questions, that'll be great. Rachel, are you there?
Thanks, John, and thanks to all our presenters. What a fantastic insight into, ways in which we can plan for a greener future. It's certainly interesting to look at the circular economy and solutions and ways of reduction, reuse, and recycling. So yes, some great questions in the chat. So first question for Professor Usha. What impact is anticipated from adopting new building technologies, such as 3D printing, on energy emissions?
Well, we've got to remember that at the end of the day, the technology is there to enable us, right? It's not an end in itself. And so I was in a panel discussion yesterday looking at the role of technology in buildings and construction and the future of buildings and construction, and at the end of the discussion, what we the agreement that everyone came to in this virtual discussion was the technology is there. It's there to help us, to enable us, but it's left to people as to how they use the technology, how the work is being elevated into a different sphere. So from my perspective, technology can do everything. It's there now to help us to get to a sustainable future. But the blockers are often people, decision makers, finance, if you look at finance from a traditional way. So to answer the question, I would say, yes, it is possible, but I think it's left to us to determine how we best make use of this opportunity.
So I'd probably add a little bit to that and totally agree, Usha. But I guess, I mean, you know, at the end of the day, it is about material technology working to deliver the kinds of products that an end user wants. So if you pick up on the example that I was presenting with plastic filaments that we've produced in a microfactory and using those plastic filaments for 3D printing, we've actually been able to print a lot of different products that people who are interested in using. Now, yes, one example is in the built environment sector where we might have really complex parts that need to be produced in a way that it's got that structural, I guess, requirements and the complex shape requirements, the geometry for a very specific application. And I think to me, that's exactly the point, that you can actually localize and use 3D printing as long as you've got access to good quality plastic filaments. So the fact that we were able to show high quality plastic filaments being produced from e-waste plastic that we do in our microfactory, that then means that for an end user to then, you know, effectively say, here's a design, here's what we need. We then can print these prototypes and people can actually go and put it in their own application to see whether it is fit for purpose or not. But I think the all important question here becomes, in this particular case, when you've got small volumes of products that you need, very bespoke products, you've got to start to think about economies of purpose. So the purpose here is to be able to have high quality products that do the job and that can come from waste resources. Then your materials and your manufacturing has to deliver the outcome. So the purpose is very much about ultimately creating an engineered and a value-added product that is fit for purpose, right? So this is why I guess I like to think of these things as creating an EVP, an engineered value-added product that allows us to make these, products that we need fit for end-user application, but an end user has to effectively be part of that collaborative journey. So a prototype is trialed and tested in situ, much like the example I was giving with Merck apartments and our green ceramics. Yes, that's a completely different technology, but the principle of collaboration, working together so that you can actually take those products, put them into real world application and have end users test it and put it through their own internal checks and balances is going to be an important part of creating a collaborative solution.
Thanks, Veena. And the next question's actually for you as well, so a nice sort of segue there. But there's a large amount of food waste in the market. There are technologies being developed for capturing the organics, but there seems to be a gap in the packaging materials, plastics and films. Is there any active research in reusing these materials?
Yeah, absolutely, Rachel, and thank you for that question, because I think, again, continuing on that theme of, how do we look at waste plastics that are going to be fit for purpose? So if you are now turning your attention to all the packaging, bearing in mind that, of course, you've got a whole variety of different materials, whether it's, a single layer, simple, flexible packaging, or indeed multi-layered, right? Because multi-layers also contain metallized layers inside. If you think about, laminated packaging that have got metallics on the inside, the typical sort of snack packaging and so on. So you've got a variety of different kinds of plastics. And the kinds of things we do with our microfactory is to really sort of hone in and say, what is it that we can actually remanufacture? So yes, if it is about plastics, and just like our presented plastic filaments, we're also producing other kinds of products that are flexible in nature, fit for all other kinds of packaging application. It all depends on ultimately what that end user requirement is. So if you want it to be sturdy and strong, and if you've got basically a really heavy duty kind of application, you want that robust packaging, or do you want to then go off on a slightly different direction and say, no, wait a minute, I've actually got good quality aluminium, for example, that I can access from this kind of food packaging. So one of our green aluminium solutions is very much about harnessing that aluminium out of a lot of packaging that sadly at the moment doesn't get harnessed. So it's very much about, again, establishing where the value lies, and of course what that remanufacturing solution could look like. Once you can create fit for purpose materials, so whether it's plastics based or metals based from the two examples, keeping an eye to what that end application and that end market requirements are, you can engineer it to those specifications in terms of quality and performance of the material and the product that you want to manufacture. So it's absolutely possible to achieve quality and performance, and you engineer that to make it fit for purpose.
Thank you, Veena. Second question for you as well, and it's in and around the micro factories, but the question is, what barriers need to be unlocked to enable establishment of smart micro factories in regional areas?
Yeah, very good question, Rachel, again, because the example that I can give of the regional micro factory that we have launched this year out at Cootamundra, that's an example where, of course, you can showcase that to be able to deliver products like green ceramics, and I showed a few pictures of that. It's very much about knowing your feedstocks. So in that particular case, we're using waste glass and waste textiles. Knowing those supply chains of materials, understanding, of course, the value that's in there. So again, talking about quality and value, and to be able to then also work out that economic outcomes. Because if you're making a product, you need to know what a customer is going to, of course, pay for those products, what are the competitive products already out there in the market, and the fact that we've created these as replacement for a lot of the market products that people can go and buy, right? I mean, someone might make the choice to use just regular tiles that are made from virgin stone-based products, and I showed examples of splashbacks, for instance. A lot of the kitchen splashbacks and a lot of high-quality ceramic materials, people are spending a lot of good money as premium products in purchasing those. But in contrast, if you can imagine if you were doing that out of green ceramics, you're creating a high value product, which means setting up a micro factory to be able to create these high quality premium products is absolutely doable, as long as you understand the entire market pull scenario. So knowing very well as to what that feedstock is, the cost of production, and ultimately what the market is willing to pay. So that means you need to understand the competitor products. And what we are finding, of course, with these examples is that end users are really focused on sustainability, and they actually want to have highly engineered products that are going to meet the engineering specifications. So it is absolutely feasible to set those up. What you really are looking to do is have a micro factory having those modules, and it is a modular setup, having those modules so that you can have as part of that supply chain of materials various participants. So we've got people who give us waste textiles, we've got the manufacturer out in Cootamundra. So having different participants in that supply chain makes it so that it is possible in a collaborative way to invest in these types of micro factories. So that initial capex investment, definitely we've shown that return on investment is very good, and I think, to me, that's the beauty of having micro factories, because that initial investment is more in the vicinity of $1 million, and it's not looking at the big mega factories that require a whole lot more investment. So that's really what has been showcased in that ABC documentary. So if people want to go back and have a look at Smart Centre's website, they'll see a little bit more details on that.
Thanks, Veena. And yeah, that might be something we can also include later, John, is the link to that if we've got that available for the participants. Thank you.
Yeah, absolutely. It's there on the Smart Centres website, Rachel, so we're happy to share that.
Great, thank you. So another question, and probably directed to Sujeeva, but question being in regards to precious metal extraction from e-waste. Is it a sustainable approach to extract, and how the industry currently handle that? Oh, my apologies, that is to Veena, my apologies. So sorry, Veena, over to you.
Yeah, no problem. I guess, I mean, if you look at, and particularly as the value of materials, and in this case, if we're talking about whether it's base metals, precious metals, you know, the things that are evident in our e-waste, copper, tin, and then when it comes to precious metals like gold, absolutely, you know, from the context of accessing a lot of our printed circuit boards, and if I may use that example, and some of the other products and components that we can get out of our e-waste, like hard drives, you can imagine that very much these micro factories are, and that video that I showed also are showcasing that it is possible to be able to harness those at a decentralized level. So you're not simply just doing the collecting and sorting and the front end of it, that physical side, but also then moving more into that thermal transformation. And the thermal transformation then allows you to produce highly customized metallic alloys. And by producing customized metallic alloys, you can then target different end users, not just in Australia, but globally. So instead of just exporting and sending away, you know, our valuable resources like e-waste, we shouldn't even be calling it as a waste. It is effectively an extremely valuable resource for electronics in a broader sense, from metals and rare earths, all of these examples. It makes a lot of sense in this whole move and push towards electrification, that we are harnessing these types of imported materials locally right here in Australia, and taking advantage of the fact that we do in the country produce a lot of these end-of-life electronic devices that, for various reasons, whether the devices have become obsolete or indeed they have stopped working, that gives us a brand new opportunity to harness these types of metallics, and absolutely they are high value materials, and so we should be pushing that journey forward. So we've been looking at potentially through ARC's funding a research hub that allows us to harness some of these extremely valuable materials from our waste batteries, for instance, targeting things like rare earths. Allowing us to pursue some of that new research with our industry partners, metal producers like Molycorp, and of course e-waste recyclers like TESAM. So there are very bold and fantastic organizations right here in Australia that are actually committed to really making this happen, onshore in the country, to harness these resources and deliver economic benefits.
Thanks, Veena. And exciting to hear that, things are happening here in Australia rather than having to be moved offshore. So final question for Sujeeva, and then, if Veena and Usha would like to add any comments to that as well. So the question is, it seems that at least initially the changes discussed in the presentations need to be implemented by regulation, forcing changes to the industry. What appetite for this is there in government, specifically Australian government, for such regulation?
Thanks, Rachel. I've actually responded to this person by text. I think the difficulty in Australia is that the states and the federal government don't necessarily align in the same direction, and therein lies a big problem. But having said that, when it comes to things like sustainability, climate change, zero waste, low carbon future, I think the federal government has definitely signaled some changes and I think that has been a result of changing leadership in the US, and Australia sort of tended to follow what happens in the US. So I think there is reason for us to be optimistic overall. But I would also like to draw on, we don't necessarily always need regulation or regulatory changes for us to be able to show that things can work, as Veena has already suggested, and through the various examples that she's given. So if you have a good set of collaborators who have a can-do approach and are wanting to change the way we do things, I think we can then take the grassroots approach and use the grassroots approach to bring changes to the top-down policy approach as well. So I hope that satisfies the person who answered the question. Thank you.
Yeah, if I may add to that, I think there are regulation changes happening very slowly, but as Usha said, yes, we can initiate things from using a bottom-up approach. But in the construction industry, we see significant changes happening. For example, the metro tunnel project has mandatory requirement of 44% cement replaced by other additives. So there are similar requirements put in. So I have seen in some tenders, there is a separate section on sustainability. So the tender bid success is also dependent on how sustainable the proposal is. So there are indirect measures that are initiating change. And also the most important aspect of this, as I mentioned before, is getting the consumer on board and enabling that behavior change to understand the culture change required in this space. So regulatory changes are happening in a very slow manner, but we do have the opportunity to create change by engaging, collaborating. I think the collaboration is the word all of us used, and that is where the major impetus for change will happen. Thank you.
Thank you all for your time and for answering those questions. I'll hand back to John now.
Thank you, Rachel. And I know there's some unanswered questions in the question box. We'll handle them, and with the help of our speakers, we'll get answers, and we'll publish them to everyone as well. So once again, I want to thank our three speakers today. What an amazing lineup! Really, thank you for your time. I know there's a lot of work that goes into this, and you most definitely have a hectic schedule. So thank you to Professor Usha, Professor Veena, and Professor Sujeeva. Thank you so much for everything. To the attendees, thank you for attending. Again, we know there's questions in the question box. We'll get to them, and we'll have them sent out to you. Again, the session has been recorded, so we'll send you a link to where you can access this recording at a future date. If you do have any questions, you can find us at millipore.com and sigmaaldrich.com. Also, I'm sure you can get access to our speakers, emailing them as well. So thank you everyone for your time. Much appreciated. We've run 30 minutes over, but what can you do when you have such an amazing lineup? So I wish you all good afternoon and stay safe. Thank you.
Thanks very much, John. It was a pleasure.
Thanks, John. Thanks, Rachel.
Thank you.
Thanks all. Bye.
Bye.